A fresh morning to all of you, grade 5. Today we are going to study a new lesson. Our lesson is page 190. Our title is What are asteroids, meteors, comets, and moons? So we are going to differentiate between them. What is asteroid? Asteroid is a piece of rock that swims in the space and revolving randomly, and it can hit a planet. What is meteors? When a piece of rock enters the atmosphere of a planet and start to burn, and if it burns it completely, we give it a name as meteor. But when it does not burn completely and a piece of this meteor hits the ground, we give it a name as meteorites. So we have asteroids and meteorites. That's what we are going to learn about today. In order to understand that, we have an activity. The activity about how something is melt and disappear. If something like what we are going to do melt and disappear, we are going to see. So in page 290, you will find this exercise or activity. Lightly place a chunk, a piece of anything, a fizzy anti-side table into a bottle of water. Describe what you observed. As the chunk fell, it began to dissolve. It reached the bottom and finished dissolving. So if you put the chunk from this open of the bottle, it will slowly dissolve it and become smaller and smaller until it finished. This is what happened to a meteor when it enters the atmosphere of Earth. So after completing the lesson, what we are going to learn to make a comparison between meteors, meteorites, comets, and asteroids. Moving to the next page, before reading the next page and answering the questions, I have this video, this wonderful video for you that we are going to share together.
From their differences in sizes to the impact they could have on Earth, join us as we explore the question, what's the difference between comets, asteroids, meteoroids, meteors, and meteorites? A whole lot of rocks. After hearing names like comets, asteroids, meteoroids, meteors, and meteorites, you likely are thinking that's a lot of names for what is essentially space rocks. And you're honestly not wrong. It does feel like a lot of names are being thrown around for as what is honestly just rocks. But you need to think of this in the grander scope of things. Because just like there isn't regular planets out there, or all stars aren't just one type, all of these rocks have a purpose in regards to their name. Even if it doesn't look like it at first, which is fine if you think about it, because most of the time we don't need to know or care about these things. But when it comes to how we look at our universe, we need to differentiate them. Let's start at the beginning of everything, okay? Once upon a time, all of these various space rocks didn't exist. Whether you believe in a god or the Big Bang, the universe didn't have anything at first, and then the wave of creation was born. For this video, we'll look at things from the Big Bang perspective. After the wave of energy and mass was delivered throughout the universe, then the gravities of various things like stars started to pull things together into tighter and tighter masses. This was how the planets got formed. But for the things that didn't become planets, they became things like comets, asteroids, meteoroids, meteors, and meteorites. Which means that these things, or at least many of these things, have been around since the beginning of the universe, and they've played a part in shaping a great many things in order to turn the universe, and even our solar system, into what it is right now. Which means that while these names may feel superfluous, that doesn't mean they aren't impactful. And in fact, each and every one of these rocks have an impact, whether you admit it or not. So let's dive into them and see what makes them so different and so special. So how about we start with obviously the most important one of the bunch, asteroids. When you think about world breakers, you're likely thinking about an asteroid, and for good reason. Although if we're being technical, not all asteroids are as big as you think. In fact, they can be quite small. The smallest asteroid that we consider to be an asteroid is about 3 feet in length, which may not sound that impressive compared to the ones that we're talking about. But you need to remember, 3 feet in length is over half the size of an average human, which means if it were to hit Earth in that form, it could cause serious damage depending on where it lands. So, if that's the smallest pure asteroid, what would be the biggest? Well, that's a bit tricky because at one point in time it was a massive rock known as Ceres. This asteroid at the time was documented as being 590 miles in diameter, which is about 1/4 the size of our moon. If that thing hit us, yeah, we'd be in big trouble. But that's the rub. It's not a threat. Not just because of distance, but because it's on an orbit that technically won't have it reach us in any conceivable fashion, bearing a massive jarring of itself. Oh, and that's the second rub. Ceres is so big that they actually made it a planet. Well, it's actually a dwarf planet, but yeah, they think it's so big that it can't be called an asteroid anymore. Which is fine, I suppose, but it makes you wonder just how many other space rocks need a reclassification. Getting back on track, the scale for an asteroid is now set between 3 feet and 590 miles in diameter. That's quite a reach, and that's partially why asteroids are so dangerous. They range in sizes in terms of lengths, and they also have a variety of sizes that make them hard to find, hard to track, and really unpredictable. Some of them are known to be dark masses of clay, yet others are bright shiny rocks made of metals like nickel or iron. Yet here's the thing. If we take all the known asteroids in the solar system and beyond, their combined mass is not even as much as our own moon. To be clear, that doesn't make them dangerous, but that helps us gauge what to expect from them, including knowing that a massive planet-sized asteroid isn't heading our way anytime soon. You might be wondering now, how is the Earth so safe from asteroids when there are so many out there? You can thank our neighborly planets for that. You see, when our universe was formed, and by that extension our solar system, it's true that there were a lot of big rocks floating around. But because of Mars and Jupiter, they were all corralled for the most part and trapped between the massive gravities of these two planets. The collisions that they caused actually created more asteroids of various sizes, but again, they're mostly trapped, meaning that Earth isn't in immediate danger of them, or at least, not yet. Before we continue to break down these space rocks and their differences, be sure to like the video and subscribe to
That part is enough about this from this video. It speaks about the uh, asteroids. Now, going back to our book, which is speak about asteroids, you can find that in page 291. Now it gives us what is an asteroid, okay? Which that they are revolving around the sun. Yes, asteroids revolving around the sun. They have their orbits. But what fixes this asteroid? What keeps them away from us? It's Jupiter gravity. There is a belt of asteroids between the inner planets and the outer planets, and because of this of the Jupiter gravity, it attracts and trapped all these asteroids, preventing them from hitting the surface of Earth. So Jupiter gravity protects us from the hitting of these asteroids. So today we have learned what is asteroids. They are pieces of rocks that revolve around the sun. These asteroids are kept or trapped by the gravity of Jupiter. Some of these asteroids, small asteroids, can come to Earth, yes, but they are not hitting Earth directly because they are going to burn inside the atmosphere of Earth. By this, we come to the end of our session today. Please go online and solve your homework. Thank you and goodbye.